Great. Hey guys. Okay, so this is part two. So you should have just finished drawing the arrows in to show this flow of energy. I'm going to put a video here about how energy leaves an ecosystem and also this idea of an energy pyramid I'm going to introduce to you. Okay, so make sure you just finish slides 1 through 20, and I'll finish this with you now. It won't take nearly as long. So where does the energy go after the lion? We saw the energy comes from the sun to the grass, energy from the grass to the zebra. Zebra's energy goes to the lion when the lion eats it, but then the lion doesn't get eaten. And it's so it when it dies, the energy can go to the decomposers. It's the bacteria, worms, fungus, things like that break down its body and get all the energy that's left in the body when you eat it. So it's like they're eating the lion. But even when the lion's alive, its energy gets used up, which makes sense because the lion has to keep eating, right? And so its energy actually gets transferred to the air. When I'm pushing the air is moving, I'm putting some of my energy into it. I'm also stomping on the ground, things like that, and my energy is leaving my body. Anybody that plays sports understands this, right? You end up moving around a lot, you produce a lot of heat, energy leaves your body, you get hungry, you need more energy, so you need to eat again. So let me talk about this box real quick. This whole unit, we're talking about energy flowing. I like to think of it like a river. It flows through an ecosystem. It has a starting place. It starts in the sun, just like a river might start at the top of a mountain. It runs through different places. It goes through producers, consumers, tertiary consumers, et cetera, et cetera. Just like the river runs through different canyons and around places. And it eventually exits. Energy does not stay in the ecosystem forever. It'll go into the air, into the ground, etc. Um, the a river doesn't stay forever. It goes usually into an ocean or into a lake, something like that. So energy moves in one direction, does not cycle back. Think about that for a second. The energy from the sun to the grass to the zebra to the lion to the decomposers doesn't end up back in the sun. Doesn't work like that. Doesn't go back to the grass. The grass can't get energy from the mushrooms, from the bacteria. It doesn't work like that. So it does not cycle. It flows. It goes in one direction, just like a just like a river. River doesn't go back up to the top of the mountain. The water cycle does, but the river doesn't. The river flows downhill. Okay, so this slide says something very similar. You get energy from your food, and you need to eat multiple times a day because the energy that you get changes into a different type. You get energy when you eat, and then as you move around, the energy turns into heat. It goes into the air, to the ground, etc. A little background, a couple slides on background knowledge about energy. We know that energy is the ability to make something move. Maybe you're familiar with the idea that there's different types of energy. If you look at this little diagram, there's actually like two big types. There's potential energy, which is like stored energy, and kinetic energy, which is actually things moving. So things like sound is molecules vibrating in the air. Heat we know is molecules moving around. Um, Wind energy, light, even electrical energy. Electricity is just like electrons moving along a wire. These are all things moving, but then you have potential energy. Things like gravity can give things energy because they fall. I have an elastic or like a bow and arrow. I can pull the bow back and let it go, and the arrow is going to shoot because I'm storing energy. It's called elastic energy. Think of like a rubber band. If you shoot some rubber band, you pull an elastic band back, you store energy in it, and you release it, and the thing flies away. There's energy stored in the nucleus of atoms, and then there's energy stored in chemicals, in fuels. That's like in gasoline, or in this case, there's like a rocket fuel here. So look at this question down here. Which of these types of energy is the type we get from our food? Which type of energy is food energy? Pause this, give that a shot, and I'll tell you later. It's good to remember that. Okay, a really big, important idea in science. This is not the last time you'll hear this. This idea is not just for food webs, it is for rockets and cars and physics and chemistry and just it's a law. It's a law of science, guys, which means it is a really big idea that no one has ever witnessed it breaking. You can't break laws of the universe. So energy cannot be created nor destroyed. It changes form. Often we say that the energy is lost, but it's not really gone. It just changes into a form that we can't use anymore. So thinking about that, so we talk about transformation. Trans would be like between two places, and formation. So this is like changing between two forms, energy changing forms. If you look here, and actually it says you right here, food energy is chemical energy. Just like gasoline, there's energy stored in the bonds of the atoms in the molecule, and we eat it, and we can turn it into mechanical energy. We can actually, it helps us move. Light energy turns into chemical energy when the plants actually take the sun's light and turn it into sugars in their body. They create chemical energy. You can plug in my toaster and it turns hot. It makes electrical energy into thermal heat energy. These are energy transformations. And many of them can be useful, but some would be unuseful, right? Like I cannot go out in the sun and get chemical energy myself. Doesn't help. When I eat and I run, I lose that energy. It's not lost to the world. It still exists, but now it is in like heat and it makes the air around me hotter. And that's not helpful. I can't use that energy anymore. So to me, in my system, it's lost. So when we're looking at energy loss, how much energy gets lost in an ecosystem, we use a thing called an energy pyramid. Now, I want you to either go to this reading or go to this video and learn more about something called the 10% rule, about how this energy pyramid works. And then you can come back and answer these questions. Even right now, you can answer these. I want you to write the words producer, primary consumer, secondary consumer. Primary means first, secondary means second. On these three lines here, these blue words, which one goes where? I'll write in some text boxes so you guys can do that. Sorry about that. And then I want you to do the reading, watch the video. The video is like 2 minutes. It's super short. And you're gonna answer this question down here. Okay, you're gonna fill in something here and here, and then you're gonna finish the question at the bottom. That's it. All you have left is the exit ticket. The exit ticket says, "Hey, there's something wrong with this food web. I did it wrong on purpose. It is a bad model. Your job as a scientist is to find the mistake in the model and explain it to me." So the problem with this food web is this is wrong because. Tell me like literally what is wrong and then why is that a problem? Why is it incorrect? And that's it. Then you guys are done with lesson 1. I'll see you guys again for lesson 2.